So hello everybody, my name's James Thomas and I'm a developer advocate for IBM working in our cloud division. And I'm here today to talk to you about what I think is a really new and exciting way to build Swift microservices, Swift backend, Swift kind of APIs in the cloud without having to set up, manage any infrastructure to be able to do this, right? No having to provision virtual machines, no having to create containers, no having to log in, install Linux environments, and all of that kind of stuff. And you might think this sounds kind of impossible, right? Swift without servers. Because surely if you want to run your Swift backend in the cloud, you need to set up and manage the environments to be able to do this. But I'm going to be showing you a new approach using something we call serverless cloud platforms that allows you to do just that. And in the second half of this talk, I'm going to do some live demonstrations of kind of using one of these platforms to give you the skills and techniques to go away and start to use them yourself. Now, as well as thinking this sounds kind of impossible, right? Swift without servers, you might also think that it sounds, you might think it sounds unnecessary. You might think, you know, I like my servers, I like my infrastructure, I like my environments. Why would you want to take them away from me? Well, the reason is this, right? Servers kill your productivity, and you might not realize it yet, especially if you're new to back-end development, but trust me, it's true. And I think by the end of this talk, you're going to agree with me, right, that servers kill your productivity. You're going to want to go back to your office, and if you see any servers, you're going to want to set them on fire and be free forever of the tyranny of looking after infrastructure, right? I think servers are one of the worst things that's ever happened to software developers. So why am I so convinced, right, that servers kill your productivity? Well, imagine you've got a great new idea for a mobile application that you're going to build in Swift, and you need some back-end APIs or services to go with it. And you know you can do server-side Swift now, so you think this is great. I'm going to do the front end in Swift, I'm going to do the back end in Swift, and everything's going to be wonderful. So you finish your front end, you finish your back end, and then you want to take your microservices and deploy them. So you go to your cloud provider, you click some buttons, you get some infrastructure, and you think you're all ready to go. But as soon as you provision those first environments, right, those first servers, those first VMs, Kubernetes, all that kind of stuff, you suddenly realize that you've got all of these extra tasks to take care of that maybe you didn't realize, right? If you're using things like VMs, you have to set up and manage those Linux environments. You have to keep it updated with new software and libraries and versions as it gets updated. You need to think about monitoring, right? You have to keep it monitoring in production to make sure it's happy. You need to think about security. Are your servers, your infrastructure, is it backed up? Is it encrypted, secure? Is GDPR compliant, as we've just heard? And you're going to need to think about scaling, right? Hopefully your application is going to get popular, you're going to get more traffic, and then you're going to have to think about scaling. And scaling means more servers. And after a while, you're going to find yourself spending increasing amounts of your time looking after this infrastructure. And I think as developers, especially if you're new to back-end development, it can feel like you get held hostage by your infrastructure, right? I want to be spending time in Xcode writing Swift, and I spend increasing amounts of it kind of logged over some SSH terminal trying to debug some kernel panic in production. And this is not really what I want to do. I just want to run my code in the cloud without really having to think about any of that infrastructure stuff. So what can we do, right? Maybe, unfortunately, you're really super excited about server-side Swift, and now I've made you very depressed because you think, oh, I don't have to manage all of this infrastructure. Well, fortunately for you, I'm going to be talking about a kind of new, or a slightly different way to run microservices and APIs in the cloud without having to think about any of that horrible, terrible infrastructure stuff. And that's called serverless computing or serverless cloud platforms. And it's a relatively new way to run code in the cloud that's really billed as this next generation cloud computing service. So let me ask the audience, right? Time for some participation. Put your hands up if you've ever heard this term before, serverless cloud, serverless computing. All right, so we're getting to around half the audience, which is about normal. Has anyone used any of these platforms before, right? Yeah, I have. Okay, that's good. So maybe about a quarter, a third of you. It's kind of what I expect. But if you've never heard of this term before, you've never really played with it, you might go to Wikipedia and you might be like, okay, what's this thing, serverless computing? And you would read things like this, right? You would read that serverless cloud platforms, they run your code in response to events. It manages your compute resources for you. They allow you to build event-driven applications. And you might kind of, again, at this point, kind of scratch your head and think, well, why is this different, right? Every cloud provider will tell you they do all this kind of stuff for you. But serverless cloud platforms are different, and they're different for a couple of reasons. And the first, I think, is that they shrink the unit of deployment. So rather than having to, when you finish your code, wrap it in some monolithic deployment package and wrap that in a big VM image and then push that up and maintain all of those kind of services, serverless cloud platforms allow you to push your raw functions, your raw source code for your microservices straight into the platform and have them executed on demand. And this is where the term serverless comes from, right? It doesn't mean that your code's still going to be running on a server somewhere in some remote cloud center's data center. But from the developer's point of view, from my point of view, all you have to focus on is your code, your business logic, not on actually any of the servers that it runs on. Now, another big difference with serverless is how it kind of handles scaling. When with serverless cloud platforms, your code gets started on demand in milliseconds to process each request as it occurs. And what happens if you get lots of traffic, lots of API requests? Well, all that happens is the platform starts multiple instances of your code to process those requests in parallel. What we call horizontal scaling. So it scales horizontally on demand, and that's quite different from kind of traditional architectures where you have a fixed amount of resource and your application sits there waiting for requests to come in. So scaling now becomes something the platform has to think about. I don't have to think about it as long as you architect your code in the correct way. When there's lots of traffic, it's the platform's responsibility to deal with scaling up. But as well as scaling up, right, to cope with loads of resources and loads of traffic, serverless platforms also scale down, and they scale down to 0. Because as I said before, your code gets started on demand to process requests as they come in. It doesn't sit there, your backend doesn't sit there idle waiting for those requests to occur. So if you have idle time with your application, periods where there's no traffic to process, guess what? None of your code is actually running. And that's really, really important when we consider the pricing model for serverless. Serverless cloud platforms, like all cloud services today, is pay-as-you-go, right? You pay, you get charged for the milliseconds that your code is running to process requests as they come in. So at the end of the month, your cloud provider adds up all those milliseconds and sends you generally a very, very tiny bill. But because you only get charged when your code's running, and your code's only running when you're processing your requests, for the first time ever, I think, with infrastructure in the cloud, you don't have to pay for idle time, right? If you've got time when there's no traffic on Sunday afternoon or something like that, none of your code's running, and you don't have to pay for it. And there's lots and lots of stories and you can go and read loads of blogs online of people talking about, having moved to serverless cloud platforms for certain workloads, saving, 80, 90, 95% off their monthly cloud bill because now they don't have to pay for any of that idle time within their application. Okay, so enough talking about serverless cloud platforms. So let's show some code. Let's actually show you how they work with Swift so you can go away and start to play with them yourself. Now, the first thing you're going to want to do if you decide, okay, I want to try out this service thing that I've heard about at the conference, is you need to pick a serverless provider. And today, there's literally dozens of serverless offerings you can choose from. But whoever your cloud provider is, I guarantee you now they have one of these serverless cloud platforms for you to play with. Even Oracle, right? Even Oracle has recently announced their own serverless cloud platform. And serverless, to give you a bit of a history lesson, began about 3.5 years ago when Amazon launched a new beta service to their cloud called Lambda back at the end of 2014. It kind of really started this whole serverless paradigm, functions as a service, utility billing, all of that kind of stuff. And that got very popular with developers. And then I think 2016 was the year kind of serverless took off because all of the other cloud providers kind of looked at that and said, this is a good idea. The service thing is going to be good. We're going to come out with our own kind of competing solutions. And IBM has one, and we're looking at today. Microsoft has Azure Functions. Google Cloud has Google Cloud Functions. There's lots of open source offerings and all that kind of stuff. But it's important to stress now, I think, that serverless is often associated as a purely AWS technology. And actually, it's not true anymore, right? Every big cloud provider has some kind of serverless offering for you to be able to use. Now, the one I'm going to be looking at today is based on an open source project called Apache OpenWhisk. This is actually the core technology at the heart of IBM's commercial offering that when we developed it about 3 years ago, we decided to open source the entire platform and donate it over to Apache, where it's going through that whole incubation process to become a proper Apache project at the moment. And recently, both Red Hat and Adobe have picked up the project and started building their own serverless offerings based on this technology. So it's getting some really, really nice traction and has a very big open source community around it now. And there is a couple of, there's some really nice reasons that if you are evaluating which serverless platform you want to be able to use, OpenWhisk I think is a really good choice. The first, obviously, is that it is open source, right? So you can go to github.com/OpenWhisk and get access to the full platform, and you can run it locally in development. You could deploy it yourself on-prem if you need some kind of on-prem thing, or you could go to a hosted offering in the public cloud and just kind of use it without worrying about it. But the reason that it's kind of IBM, who developed OpenWhisk, decided to open source it, whereas most of the service offerings today are kind of commercial and proprietary, is that we think everyone if you're developing in the cloud, there's lots of worries about vendor lock-in, right? What if I build on this platform or API or service and they just turn it off or it goes away? Remember what happened to things like Parse.com? So we think by open sourcing our cloud platforms and building on open source cloud platforms, you have a little bit more security long term, that even if IBM goes away, that you're still going to have a way to run your OpenWhisk serverless functions. But actually, the best thing about OpenWhisk, I think, is the runtime support. So with Service Cloud Platform, as I said, you write your functions, your serverless functions, your code, you push it into the platform, and it gets executed on demand. And you don't have to set up and manage the environment which runs your code. But that means that you're kind of very much dependent on the cloud provider, the serverless platform, to give you support for the languages that you want to be able to use. And if you look across the different providers, language support is very, very provider specific. So most of them support some version of Node, right? Node is the first-class service language generally, and it's supported on pretty much any platform. Java and Python are also relatively popular choices as well for runtime support, and OpenWhisk supports multiple versions of all of those languages. OpenWhisk also has support for things like PHP and Docker and static binaries. I'm not really going to go into too much. But the best thing, I think, for many of you in this room about OpenWhisk and serverless is that it has native support for Swift in the platform. So you can push up raw, uncompiled Swift functions straight into the platform and have them executed on demand. And it's the only platform at the moment which has that kind of native Swift support, which is pretty awesome. Obviously, IBM has been pretty heavily involved in Swift since it was open source, doing things like the open source foundation libraries, work on the language, doing things like Couture as well. So we're heavily invested in Swift as a language. It was a really natural choice for us to then add that into the platform when we're developing it. So once you've chosen your serverless platform and you've written some code for it and you push your code into the platform, the question people have is, okay, so like, how does the platform know what to do with my code? You said it just push it in and it executes on demand, but how does it know how to call it and what functions it call and all that kind of stuff? Well, the way it works with serverless is, imagine you have this mycode.swift file, right, with some real Swift code, but it's not too important what it is. And this could be, written in any language, right? What happens is when you push that into the platform, to make it compatible, what you have to do is you have to add a particular function name to that file, that JavaScript file, that Swift file, that Java file, and that's going to be the interface from the platform into your code. So when an API request comes in, the code gets evaluated, and it's going to call that function with the event parameters, and whatever you return will be serialized back out as a response of your kind of API request. So obviously, the function handler is different for every language, and this is what it looks like for Swift. So imagine I have this big file, and it can be hundreds of lines long. This is what the function handler looks like for the Swift 3 runtime. So you need to have a function called main, which is going to be the entry point. It's going to get past a dictionary of type string any, and then you need to return a dictionary of type string any, and the platform's going to do the automatic serialization to and from JSON in the platform. You can see it's very, very lightweight. It's not very complicated, and that's pretty much the only configuration that you need to do to your Swift code to make it compatible for the platform. Now, initially, when Swift support was added into OpenWhisk, it was based on the Swift 3 runtime. And recently, obviously, we now have Swift 4. And one of the great things I think about Swift 4 is what they call Cobol Protocol, which makes it much, much easier to translate automatically between native Swift types and things like JSON automatically using the language. So as of a couple of weeks ago, they released Swift 4 support in OpenWhisk. It means that you can deploy Swift 4 functions. And they actually took full advantage of the Cobol Protocol and kind of changed the function interface that you can use to make this much nicer. So if you're using the Swift 4 runtime actually now you can be receiving and returning native Swift types, right? So you still have a function called main, but this time, rather than having to deal with having a dictionary of string any and do all those optional checks and that kind of stuff, you can actually have native Swift types passed into your function and return whatever you want, and they will be automatically serialized and deserialized to the JSON that comes back and forth. So once you finish your, in this case, we're going to be writing some Swift functions or Swift file. You add your little function handler called main, which acts as the entry point, and you push it into OpenWhisk to create some serverless functions. OpenWhisk will create what's called an action. So an action is just the name that we use in OpenWhisk for serverless functions. I think of actions as like sleeping microservices ready to be woken up to process requests as they arrive. So let's have a look at actually doing that now. Let me take some sample Swift code from a laptop, deploy it to OpenWhisk, and show you how easy it is to kind of get started with the platform. So let me hide my slides, and then hopefully mirror my screen. There we go. Okay, cool. So OpenWhisk is, as I said, it's completely open source, and this is the GitHub repo at Apache at the moment. And it means that obviously you can download, you can run the whole platform locally in a VM or using Docker containers and Docker Compose. If you just want to play around as development and testing, you can deploy it yourself and use it like that. Or you could go and use one of the managed OpenWhisk offerings from someone like Adobe or IBM. And that's what I'm going to be kind of doing today, because I think that's kind of easiest. And the point of serverless is to not really manage any of the infrastructure. So we're going to be using something called IBM Cloud Functions, which is essentially just a managed version of the open source platform running in the public cloud. Like all cloud providers, you sign up for free, you get a super generous free tier, so it's very, very easy to get started. Now, whichever OpenWhisk endpoint you're going to use, whichever OpenWhisk platform, you need to be able to get your code from your environment, from your development environment, over to the OpenWhisk platform and deploy it. And to do this, essentially, is a little command line utility you download and install into your development environment that you can then create serverless functions, invoke them on demand, debug them, and all that kind of stuff. So this is instructions of how to do this, which as an OpenWhisk user, I've already done. So let me make that a little bit bigger so you can see my command line. All right, can people see? Okay, just about. Okay, see some nodding heads. That's good. So I have this command line, bxwhisk, that essentially allows me to interact with the platform and create some serverless functions. So let's go through like a hello world, what I think of as like the hello world example for serverless. So I have, I think it's called hello.swift. I have a little Swift file here called hello.swift, which actually implements like the hello world for a serverless function, right? It's just has a function called main, which is obviously going to be the entry point of the platform into our code, and it essentially just returns you a greeting. It says, hello stranger, or hello James, or hello Sally, depending on the name that you might pass in as the event parameters. So let's have a look. Let's just do the hello world introduction and get this deployed and working really, really quickly. So what I need to do is I can say bxwhisk action create, and then I say give it a name, call it hello, and then I give it a path to the source file. And it's going to show me that it's created the action on the OpenWhisk platform. I can see that it's been deployed, so I can say, okay, it's in my workspace using the Swift 3.1 runtime. And it means now I can test out, right? I can invoke it. I can say, okay, action invoke hello. And what should happen is it should find an environment, inject my code, evaluate it, and give me back the response of that Swift code being executed somewhere in some server that we'd have to think about at all, right? So you can see it can work, right? The result of my function, the dictionary, gets serialized back out to JSON. And I can try this again with names. So I can say, okay, give it my name, James. And it's just going to say, hopefully it's going to say, hello, James. Or I can try Sally, and it'll say hello, Sally. And all I've done is written some Swift code, and I deployed it. And now I could invoke this serverless function like 1,000 times in parallel, and it would just work. I don't need to think about VMs or load balancing or any of that kind of stuff. Now, obviously, this is like the hello world example, right? It's not a particular realistic microservice that you'd want in your application or for your backend. So let's look at something that's maybe a little bit more realistic. Imagine you are developing a mobile app for a retailer, right? So you buy stuff through the mobile app. And the retailer comes to you one day, they've had the brilliant idea that they want to integrate Bitcoin into their application, right? They want customers to be able to pay with Bitcoin during the checkout process for whatever reason. What the problem is, obviously, Bitcoin as a currency fluctuates enormously, like, day to day, hour to hour, minute to minute, the price changes. So you can't embed static Bitcoin prices in your product database. So what you think you'll do is you'll have some kind of API that you can call during the checkout process to do kind of real-time conversion of some currency into Bitcoin during the checkout process. And you think this is a good use case for serverless. So in true Blue Peter fashion, here's a microservice I prepared earlier. And essentially, it's some Swift code to implement that API we've just talked about, right? And it's relatively simple, right? You have a function called main, which again is going to get called with some parameters. It's going to look for a currency and amount, right? The currency and amount to convert into the equivalent amount of Bitcoins. Then it calls another function which just essentially does a HTTP request over to CoinDesk. CoinDesk is a Bitcoin wallet, and they publish real-time Bitcoin prices into the currencies. So it does that, it passes the JSON, and then it comes back down the bottom. And it just does a bit of maths down here, just to obviously convert from your currency for the product into the equivalent amount of Bitcoins. So I can deploy that using the same approach, right? I can say bx whisk action create Bitcoin, and I give it conversion.swift. And it's going to say, OK, that's been created. So I can check it's been deployed. Yeah, that looks fine. And now I can try it out. So I can bx whisk action invoke Bitcoin. And I need to give it some parameters, right? I need to give it an amount. Let's try like 10,000 because Bitcoin is super expensive. And a currency, let's just try dollars. And hopefully it's going to evaluate that Swift code, which is going to make the external HTTP call. It's going to pass a JSON. And it's going to tell me that 10,000 US dollars is 1.3679 Bitcoins at the moment. And I can call this again with like euros, and it's a little bit more. And I can try with pounds. And you can see as a pound is 10,000 pounds is around almost 2 Bitcoins at the moment. So really, really quickly, I've been able to take some Swift code and deploy it to one of these service cloud platforms, and then now kind of execute it on demand and check that it's working without having to see or think about a VM in sight. So once you've got your serverless functions deployed, the next question to answer is, OK, but how can I integrate them into my application? How can I kind of invoke them programmatically? I'm not going to do that during the command line. You can test things, but it's not going to be how I'm going to call my serverless functions programmatically. Well, OpenWhisk has a couple of different ways to be able to invoke serverless functions programmatically. And the first is through something we call the Platform API. So OpenWhisk has very well documented RESTful HTTP endpoints for the entire platform that you can just interact with by sending authenticated HTTP post requests to invoke serverless functions programmatically. So any application, mobile or otherwise, that you can send an authenticated HTTP post from, you can invoke your serverless function on demand. And actually, when I'm using the command line interface and typing whisk action invoke, all the command line interface does under the covers is sending HTTP requests over to the platform API. And actually, there's client libraries available for Swift and JavaScript and other languages to make this process of programmatically calling your functions even easier. It's just like a method call rather than you having to manually construct that request. Now, to use the platform API, you need to be sending requests that are authenticated with your developer credentials. But if you're building APIs, often you want these to be public. You want anyone to be able to call it without having to obviously share around your private developer credentials you've signed up for. So OpenWhisk actually has two different ways to expose serverless functions as kind of public URL endpoints. And the first is using something we call web actions. So when you're creating your actions on the command line, there's actually a configuration flag you can set called --web to be true. And what that does is it turns your action into what we know as a web action. And web actions have a unique URL that's been generated by the platform that you can access to invoke those functions programmatically, but without requiring any authentication. So you still send a request to the platform API using HTTP post, but this time it doesn't require your developer credentials. And actually, if you just need a really, really quick way to expose a HTTP endpoint, maybe for just a webhook, or maybe you're creating a chatbot, something very, very simple, not high traffic, web actions are a really, really good way to be able to do this. But if you are building bigger, more high traffic, more enterprise API endpoints, you're probably thinking, OK, but what about like API routing? I want different serverless functions to be invoked based on the request parameters coming in, right? The path, the route of the HTTP request. What about rate limiting? I want I don't want people to call my serverless functions too much. Maybe it's going to cost too much. It's going to blow up some downstream services I use. What about authentication, right? I want users to be able to pass in their credentials that I can use with third-party services and use things like OAuth. And if you are creating your endpoints using web actions and you would like to have things like routing and rate limiting, you actually need to implement those features kind of manually within the code. So you need to look at the request parameters coming in, and you have to work out in the Swift code or other language how to do things like routing and rate limiting. And it's not a very scalable approach. It's not really a recommended approach for building bigger kind of high traffic APIs. So what everyone does in the serverless space, if you're going to be doing this kind of thing, is they use external services called API gateways. All big cloud providers have these kind of API gateway services in as part of their kind of cloud offering. And what they allow you to do is define public HTTP endpoints for your domain or for the API gateway domain that then will proxy private API calls in the background without obviously exposing your keys. And the great thing about API gateways is that they can handle all of those things we just talked about for you. So they can handle rate limiting and authentication and routing at the API gateway layer, which means you don't have to think about it in your code anymore. So let's have a look at doing this, right? Let me take my Bitcoin function, actually expose it first as a web action and just show you how that works, and then make it a kind of fully fledged managed API gateway endpoint. So let me go back to mirror my screen. Okay, that works. And let's do this. So let's start with on the command line and let's expose the Bitcoin function as just a web action and show you it working. So what I'm going to type is going to say bx whisk action. I'm going to say update because it already exists. And I'm just going to set that flag --web to be true. And now what I can do is if I use the command line to retrieve details about the Bitcoin function and I pass in the URL flag, it's going to give me back a URL on the platform that I can call without any authentication to invoke my serverless function. So I can test this out, right? I have this little utility that allows me to make HTTP requests to the command line. And I can copy that, and I can paste it, and then I can say, okay, JSON. Oh, and I need to put it in brackets because I need to pass some query parameters, and the way you pass query parameters is URL parameters is just by using query param. So amount like 10,000 and currency equals $. And hopefully it should just give me back some JSON, which is the result of calling that serverless function. But this time, again, calling the platform API, but with no authentication. It's just now a public URL endpoint that pretty much anyone in this room could call and really, really quickly turn that flag on to make it publicly available. So there we go, right? It works really, really quickly. And that's web actions are just a great quick way to expose your functions as public endpoints. But imagine my Bitcoin endpoint is going to be very popular. And so I want to do things like rate limiting or authentication for users. So I want to turn it into a fully managed API gateway endpoint. Now, OpenWhisk, nice thing about OpenWhisk is it comes built in with an API gateway service, and you can manage this through the command line. So I can type like Whisk API create, Whisk API delete. But I think it's a bit more intuitive if I show you through the management console for IBM Cloud Functions. So if I go to my browser, you can see this is just the kind of nice management UI you get for OpenWhisk running on IBM Cloud. And you can see down the bottom I have this APIs tab, which if you click, goes to this page where you can create API gateway endpoints for those functions. So let's do that now, right? So I'm going to create me an API. I can give it a name. Let's call it Bitcoin. You can choose a domain. Let's choose the default domain because I don't have one installed. And now you can set up things like routing, right? So now you can have the API gateway route different operations to your serverless functions rather than you having to think about it in your code. So you can say, okay, for get request to the subpath Bitcoin, I'm going to call my action Bitcoin. It's going to return me some JSON. That's great. And you can see I can turn on all those cool things we talked about. If you want to do authentication or rate limiting or OAuth or CORS, this becomes a configuration flag and I don't need to think about it in the code anymore. So I click Save, and hopefully it's going to give me back a URL for the API gateway that I can then invoke my serverless function rather than the platform API. So it's giving me a route here, because I don't have a new route because I have my own domain. And it should just work in the same way, right? So I can say HTTP GET API/Bitcoin amount equals like 10,000 and currency equals like $. And you can see this time, hopefully the results should be like exactly the same. Right, I should say $10,000 is about 1.36 Bitcoin, right? See that, you see it's worked, right? Bitcoin has changed price in the last minute, right? So it's a little bit cheaper or more expensive. But actually, now I'm calling a completely different URL. This is not the URL for the platform. This is an API gateway, and this could be your own custom domain or something like that. But now I have the ability to turn on all those features we talked about, like routing and rate limiting, without having to think about it in my code, which is really, really nice, I think. So in examples of just been kind of walking through building APIs, you're kind of building serverless functions that you want to invoke programmatically, right? I'm going to want to call it from application. I'm going to call it. I'm going to block waiting for the response to come back, like a remote procedure call. But another big use case for serverless that we often talk about is building what we call like event-driven applications, where you want your serverless functions to be automatically invoked when, say, a message gets pushed on a queue or a database gets updated without you having to manually do this through the platform API. And all serverless platforms support this kind of event-driven architecture, and OpenWhisk is no different. So in OpenWhisk, we have this concept called triggers, and you can, again, using the command line, create triggers within the platform that listen to these external event sources like databases, like message queues. And when you create a trigger and you connect it to one of these external event sources, the platform will start listening to that external event source and automatically firing your trigger with any events that occur without you having to do anything at all. Now, all serverless platforms generally support this thing where you can connect your functions to events and have the platform listen to them on your behalf. But the event sources they support is very, very provider specific. So these are the ones that come kind of out of the box with OpenWhisk, right? We have support for Apache Kafka. Apache Kafka is a very popular open source and distributed message queue, very high volume, very, very popular at the moment for event streams, event logs. And you can have triggers listening to messages on Apache Kafka. There's an event source for CouchDB. CouchDB is a very popular, again, NoSQL open source document database, and you can have triggers listening to that. There's an event source for RSS feeds, for mobile events, for GitHub. There's also one that's quite useful for what they call the scheduled or the clock feed, where you might want to have a trigger with some event called every 5 minutes, maybe every hour, every day, to kick off some background processing. And in OpenWhisk, when you've created one of these triggers that listens to an event source, you can then create what we call rules that bind together your action and your trigger. So you can create a rule so that when the message gets pushed onto message queue, the trigger gets fired with those parameters in the platform, and your serverless functions, your actions are automatically kicked off. And you can have multiple serverless functions all listening to the same trigger, all listening to the same event source. And this is how we can start to build event-driven applications using OpenWhisk, which is another really, really big aspect of using serverless cloud platforms. So, hopefully I've started to share with you why I'm so interested and excited in serverless cloud platforms. And maybe you start to believe me, right, that this stuff's really, really cool, and you're ready to go back to your office and start setting fire to all of your infrastructure. But before you do this, it's only fair for me to talk about some of the challenges of using serverless cloud platforms today, because they are, they, like all architectural choices, it comes with trade-offs and constraints and some rough edges. And serverless is very new, relatively, and definitely has some of those. So I'm going to talk about two big challenges that you might run into, and also talk about some kind of solutions or workarounds. So the first challenge you might run into is understanding the difference between what we call warm versus cold activations or invocations for your functions, and the effects this can have on the performance of your APIs or your endpoints. And this is a particular characteristic of how serverless platforms work, but it really, really affects the Swift runtime more than some of the other things like JavaScript and Python. So let me explain what I mean by this. What's the difference in warm versus cold activations? Well, when I was doing my demos before, right, if you're really, really paying attention, you might have noticed that the first time I invoked a function after I created it, it was always a little bit slower than subsequent invocations, right? And this delay wasn't due to some like bad Wi-Fi or intermittent network issues, right? It was an inherent characteristic of how serverless cloud platforms work. The first time you invoke a function, we call this a cold activation or a cold invocation, and subsequent invocations, it's known as warm. And warm invocations will always be so not significant, but will always be faster than cold activation. So why is this, right? Why is it the first time you invoke a serverless function, it's a little bit slower? Well, to explain why this is, I'm going to give you a very, very brief overview of how serverless cloud platforms work. So when you type on the command line Whisk action invoke, and the CLI tool sends a HTTP post over to the platform API, a number of steps need to happen before you get back the result of your function, right? Whatever it's returned serialized back out to JSON. And for Swift, this is a very high level of the steps that are required to evaluate your code. So on the left-hand side here, this is for a cold activation. And the first thing it does, it starts a container in the background very, very quickly, efficiently, which is going to be a Docker container as kind of the runtime that all serverless platforms use to execute code on demand. It's going to inject your code into the file system. It's going to run Swift build, because Swift is a compiled language, so we need to turn it from the source code into a binary. It's going to invoke the binary. It's going to call your function. It's going to pass in the event parameters. You do your code, and then whatever you return is serialized back out as a response of the platform API. And normally the source of the delay for cold activations is that Swift build step, right? Swift build is not known for being super fast. So to improve performance for subsequent activations, subsequent invocations, what happens is that rather than just throwing away that container, right, with the environment in, what they do is they pause it, so it doesn't run when you're not using it. It gets paused. The next time you invoke your serverless function, that container gets resumed. It doesn't need to inject the code because it's already there. It doesn't need to run Swift build because the binary has already been built. Just calls the binary again with the new event parameters, and whatever you return is serialized back out as the response of the second request. And that's why subsequent invocations are often a bit quicker. Now, the question you have to then ask yourself is, does this matter to you? Does this affect you? If you're building a little serverless function, maybe just to listen to like a webhook or to process messages on a queue, you probably don't really care whether it takes like 1 second or 3 seconds to finish the kind of end-to-end request. But if you're building APIs that for front-end apps or mobile apps, maybe performance and latency is something you're really, really concerned about. So what you can do is this, right? Here's a trick for you that everyone does. What you can do is you can actually deploy the Swift binary rather than the Swift source code. So you can run the Swift build locally as part of your deployment process and create your function from the binary. And when you do that, what happens is during the cold invocations, your deployment package gets injected into the file system, gets unzipped, the binary, and it detects there is a binary there. So it doesn't run the Swift build process, and it just invokes it as if it's kind of warm execution. And that can dramatically reduce any delay from the Swift build for cold invocations. And if you're building production APIs with serverless cloud platforms and Swift, on serverless, you would always pretty much deploy the binary, right? In testing and development, it's fine just to play around, or even if you don't really care about performance, but if you're going to go for production APIs, you pretty much always run the Swift build locally and deploy that rather than the source code. And this affects Swift obviously much more than other runtimes. The JavaScript and Python, it's just evaluated, so it doesn't really matter. They have to run any kind of build step prior to calling the function. Okay, the second challenge that you might run into, this is not specific to Swift, right? This affects all of runtimes equally the same. And it's around the limits that the platforms place on you in terms of the resources you have available to you. Serverless cloud platforms they're very opinionated architectures, and they're opinionated about the kinds of applications they expect to run, right? It's for modern cloud-native microservices that, scale horizontally, are stateless and all that kind of stuff. It's not for, you can't lift and shift some kind of legacy app over to running on a serverless cloud platform. Not that we don't really have any legacy Swift apps today, but just in case you thought you might want to do that. And so one of the ways that serverless cloud platforms make you build applications in this architectural style is by limiting access to some of the resources that you have available on the platform. So these are some of the limits that OpenWhisk puts in place in terms of running code on the platform. And most serverless platforms, they all work in the same way, so they all have the same kind of limits. But the big two you will run into, if you're used to more traditional infrastructure and having like physical servers, is one, timeouts, right? Timeouts is a big one. When your function gets called to process a request, you have a maximum of, on OpenWhisk, it's now 10 minutes to finish processing that request and return. If you haven't, you're still doing some work, or the platform will kill the process off and will return an error code through the platform API. And all service platforms have this limit. Most of them is around 5 minutes. OpenWhisk is about 10, but it's in the order of like minutes. It's not hours. So if you have a bit of your application that takes like an hour to compute and you can't parallelize the work and run it in parallel, It's not going to be suitable for running on serverless platforms. They're not designed for very long kind of batch processing work. Another big one that people run into is memory. So you actually get before I told you, you get charged for the milliseconds that your code is running. Well, that is true, but it's the time your code is running multiplied by the amount of memory that it allocates. So the more memory you allocate in your function during processing, the more the pennies that it costs you essentially. And you can change the max amount of memory for a function. So you can say, you can control the cost by bringing the memory down, or the maximum memory down, or you can improve performance by giving a function even more memory. But the amount of memory you can allocate for a function, or a function can allocate, is in the order of like a gigabyte or half a gigabyte. It's not in the terabyte range, right? OpenWhisk, it goes up to half a gigabyte per execution at the moment. Some of the platforms go to like a gigabyte and a half, but none of them are ever going to be close to the terabyte range. It's not really designed for that kind of workload. So again, if you have some kind of workload that needs either very severe performance requirements, you need terabytes of RAM, you need GPUs to be able to compute, it's not really designed for that. Serverless computing is not for kind of very high performance workloads at the moment. So around the resource limits, right, it's really, really important that you get to know the resource limits for your serverless cloud platform, and that you kind of embrace them. They're there to help you to build your architecture to support running and scaling in the public cloud. Don't try and lift and shift and then complain that it doesn't work. So I said at the start of this talk that servers kill your productivity, and hopefully maybe now you agree with me, right? All that time spent patching kernels and managing VMs and upgrading middleware is actually time that you're just kind of wasting, right? It's not really time spent on your product, on listening to users, on pushing out new features, on fixing bugs. And I think as developers, especially if you're new to backend development, it can often feel like you are held hostage by your infrastructure after a while. So I want to encourage everyone here, right? If you're starting to get into backend development, maybe you're thinking about it, server-side Swift, think about embracing the serverless revolution, right? Burn your servers, deprovision your VMs, delete your containers, and be free forever of the tyranny of looking after infrastructure. But more importantly, upgrade your productivity, right? Stop spending your time managing VMs in some sprawling cloud provider's data center and get back to actually writing code. So thank you very much for listening. If you want any of the resources from this talk, probably take a photo of this screen, or the slides will be available after. That link at the top will take you to a GitHub repository with all the demos and the code and slides and videos for you to play along at home. If you like OpenWhisk and you think this is pretty cool and you need some help when you get started, come and join us in Slack. We have a Slack for the open source community. It's very, very popular. And also Stack Overflow, if you tag your question with OpenWhisk, someone like me will probably come along and answer it for you relatively quickly. Or if you need any help or you want a more personal introduction, then I'm on Twitter, or you can just @OpenWhisk, and someone will jump in and help you get started. So thank you very much for listening. And then if you have any questions, then I can do them now.
Brilliant. Does anyone have any questions? Lots of questions. Can I just grab the microphone,
Yeah.
please? Cheers. So, Johan Quist was the first one I saw.
Quick one about the invocations.
Yeah.
How long does the container stay paused for?
How long does the container stay warm for?
Paused, yeah.
Yeah, so, it varies on platform. OpenWhisk is about 10 minutes.
Okay.
Another kind of slight aside is that container environments that processing requests they only process like one request at a time. So your cold invocations is not just for the first time, it's also if there's not enough in the cache and that kind of stuff. But yeah, around 10 minutes. There is a trick if you're desperate to have warm containers where you can attach that schedule function to call it every 9 minutes and 59 seconds, which people do a lot. But yeah, around 10 minutes normally.
Cool, brilliant. Thanks, great talk. Cheers.
All right, thank you.
Any other questions?
Is there another one at the back, I think?
Yeah, one here.
My only question, actually, because it's a really good talk, thank you, but
Thank
my
you.
only question is, where's the data?
Where's the data? Good question. That's good. That's a very common question. It's actually something I'm going to cover in a new talk about serverless. So yeah, normally you push it out. So people are like, okay, so I have no server, I get that, but then yeah, where's my database? Where's the message queue? And it can be a bit of a confusing if you're used to a physical machine. So generally, with serverless, I think my motto is you kind of embrace the cloud, you embrace your provider. So if you want a database, you don't then go and provision a VM and manage that yourself. You go and use whatever the provider's managed database offering is. So you can, you're using it also as a kind of managed service. So you don't run the data. Generally, I mean, you could do, right? Your code can talk to a database anywhere. But generally, what most people do is they use managed services for their database, their message queue, and their, I don't know, what other things you need, because you try and get away from managing any infrastructure whatsoever, and you leave that to the cloud provider, you leave that to your service provider. So for your data, it will be in a third-party database that the serverless function will just talk to over, an API or some kind of endpoint or connection, and you leave that for the cloud provider to manage.
Cool.
Cool.
Any other questions? So I'll hand over here.
It's so bright up here.
No. Cool. In that case, thank you very much. Let's show our appreciation for James.